Alrighty, let's get started on this next lesson. This is the lesson on scattered plots and correlation. Let's start with our do now. The school newspaper surveyed the student body for an article about club membership. The table below shows the number of students in each grade level who belong to one or more club. If there are 180 students in 9th grade, what percentage of 9th grade students belong to more than one club? Alright, so we know that the total number of 9th grade students is 180, and now they want those that belong to more than one club. So I don't want one club. 2 clubs would be more than one club, and 3 or more clubs would be more than one club. So I need to do, what is 33 plus 12? I get 45. Alright, so now we have 45 divided by 180, which would give us 0.25. And if we times that by 100 to get a percentage, we would get 25%. So we can say that the percentage of the 180 ninth graders who belong to more than one club is 25%. Alright, so that was just a little review of yesterday's lesson. Make sure that you turned in the homework from yesterday. And today we are going to be going over creating scattered plots and determining the correlation between the two variables. Alright, let's look here. For 10 days, Romero kept a record of number of hours he spent listening to music. The information is shown in the table below. So this is the amount of days, and these are the amount of hours. And they want to know which scattered plot shows the data graphically. Alright, this shouldn't be hard. I need to have 1 day with 9 hours. Well, 1 day, this one has nothing, so that can't be our answer. Alright, 1 day with 9 hours, that looks good. 1 day with 9 hours, that looks good, and 1 day with 9 hours. Okay. Now, 2 days with 3 hours. 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 Alright, so far, so good. 3 days with 2 hours. 3 days with 2 hours. 3 days with 2 hours. 4 days with 6 hours. 4 days with 6 hours. 4 days with 6 hours. Well, this has 2 dots on 4 days, so it's not going to be this one. And then 4 days with 6 hours. Alright. Now we have 5 days with 8 hours. 5 days with 8 hours. And 5 days. Ooh, there's no 5 days here, so it's not this one. So our answer would be choice 2. Basically, all a scattered plot is we take the data that we found in a survey. Here we found about the days that he was listening to music and how many hours he did, and we were just plotting the points. You do not connect the points when you make a scattered plot. That's why you do not see the points connected here. Alright, let's think. We have these 3 different scattered plots. Question 1 says, if one of these scattered plots represents the relationship between the height and weight for 8 adults, which scattered plot do you think it is, and why? Okay, between height and weight for 8 adults. Well, if we think about it, if we're talking about how tall somebody is and what they weigh, normally they both increase together. The more taller you are, the more you weigh, normally. So I would say scattered plot 1. And then why? Because generally, the taller you are, the more you weigh. Because generally, taller equals way more. I'm just abbreviating here. You would write a better sentence than me. Alright, question 2 says, if one of these scattered plots represents the relationship between height and SAT math score for 8 high school students, which scattered plot do you think it is? Well, if I chose scattered plot 1, that would be saying that I think the taller you are, the higher your SAT score is. Or the second one, I would be saying that the shorter you are, the lower your SAT score. Or does it make sense that it's all random, like scattered plot 3? I would say 3. Because no relationship. Doesn't matter if you're tall, short, your SAT score just depends on what you know, what you don't know. Height doesn't have to do anything with that. Alright, question 3. If one of these scattered plots represents the relationship between the weight of the car and the fuel efficiency for 8 cars, which scattered plot do you think it is? So this is saying, as your car weighs more, do you think your fuel efficiency would go up or down? Well, if you know anything about cars, the weight of your car would make your fuel efficiency go down, which is scatter plot 2, because more weight equals less fuel efficiency. All right, and the last one. Which of these 3 scatter plots does not appear to be a linear relationship? If you remember anything about linear relationships, that's when it generally forms a straight line. Like this first one generally forms a straight line, the second one generally forms a straight line, but the third one does not. So you would say the third one is not linear because the points are everywhere. All right, let's look at this next one. What is correlation? Correlation is a measure of the relationship between 2 variables, so whatever variables on your x-axis and whatever variables on your y-axis. And this can create either a positive or negative correlation, or if you see that the dots are everywhere, all mixed up, that would be no correlation. Now, when the dots are really, really close together, that creates strong correlations because you could clearly see the line pattern that it's starting to form. But when the dots are a little bit more scattered, that would be a weaker correlation. And these are some examples here. All right, individual practice. A survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and high temperature. Construct a scattered plot using the given graph. All right, my low temperature was 26, so this is 20, they're going by 2s. So 22, 24, 26, and then we're going up to 49, which would be somewhere right here. These graphs are going by 2s as well. So this would be 48, 46. All right, now we have 28 and 50, which would be right here. Keep pressing that. Then we have 30 and 57. That would be 52, 54, 56, 58. Let's go like right there. All right. Then I have 32, 30, 32, and 54. 50, 52, 54. Then I have 34, 30, 32, 34, and 60, which would be right here. Then I have 35 and 58, which would be right here. Then I have 37, 32, 34, 36, 37, 37, and 64. That's 60, 62, 64. Then I have 38. Oh, I need to put this one a little bit more over because it's 37. So 40, 38, 37, and up to 64. All right. Now I have actual 38 and 66. Then I have 41, so a little over from 40, and 63. This is 60, 62, 63. And then lastly, I have 45, 42, 44. 45 would be somewhere in the middle, and 72, which would be right here. Alrighty. The question says, what is the correlation shown? We would say let's just see if we were to make a line. If I make the line, they're kind of around it. They're not exactly on it. So I would say a moderate, positive correlation. All right, we got another example here. A survey was done at Ketchum High School to determine the effect of time spent studying and grade point average. The table below shows the results of 10 students randomly. All right, so we got 2 students, and their GPA is 64. All right, we got 4 students, and their score is 71. We got 5 students, and their score is 69. Then we have 7 students. 2, 4, 6, 7 would be somewhere here. 7 students and 74. Okay. Then we have 10 students and 81. Then we got 12 students and 86. Then 14 students and 84. Then we got 17 students and 94. All right. Then we got 19 students and 91. And lastly, we have 20 students and 96. Alrighty. What is the correlation shown below? I would say this is a pretty strong, moderate to strong, positive. Because some of them are on the line, which make, when I drew that line, the dots fall directly on the line, which makes me feel like it's more strong, but they're not perfectly, so that's why I said moderate to strong. All right. The scattered plot shown below represents a relationship between x and y. The type of relationship shown is, well, if I try to draw a line here, it's definitely positive. It's not negative. We are able to determine it, and it's not 0 because it's not all scattered around. All right. A line of best fit has been drawn on the scattered plot shown below. The relationship between these values can be described as having what? A positive correlation. All right. Which statement is true about the data shown in the scattered plot below? There's definitely some type of correlation. It's definitely not positive. And it's not negative and positive, so it is there is a negative correlation between the two sets of data. And let's look at this one. The scattered plot below represents the relationship between the number of peanuts a student eats and the student's bowling score. Which conclusion about the scattered plot is valid? All right. Well, I see it's all scattered around. That generally the number of peanuts is all around the same amount of bowling scores. There is almost no relationship between eating peanuts and bowling scores. Students who eat more peanuts, so the ones who eat more peanuts, have higher bowling scores. Well, I don't necessarily see that going up, because look, this student eats 50 peanuts, but their bowling score could be between 50 or 100, or it could be close to 250, so I don't think it's that. Students who eat more peanuts have lower bowling scores. I don't think so, because they could be high or low, as we see with the 50 number of peanuts. It's definitely not that no bowlers eat peanuts, because we see some bowlers eat 50, 60 peanuts, so it would be that there's almost no relationship. And that wraps up our lesson on scatter plots and correlation. So there is now an exit ticket to be completed, so you can practice solving more Regents problems that have to do with scattered plots. And that wraps up the lesson.